Hello everyone, welcome to this lecture series on differential equation. So differential equation form one of the most important topics of a mathematics as a powerful tools to model and solve a wide range of real life problems in engineering and science. So in this course, I will explore the fundamental concept, techniques, and application of a differential equation in a systematic way. So our first lecture is based on the introduction to differential equation. So first of all, I will explain the definition of a differential equation. So application is a differential equation. DE I will use as a short form. DE for differential equation is an equation which involves differential or differential coefficient. Okay, first of all we have an equation. Okay, so that equation, we have an equation, and that equation has contains different derivatives or differential coefficient. So then that equation is said to be differential equation. So let us suppose that this is an example of a differential equation. Okay, px is any function of x and qx is any function of x, and in this equation, this is an equation is contains an equal sign. So this is a coefficient of the derivative dy dx. The terms of a derivative exist in this equation, so then this equation is said to be differential equation. Okay, so our definition is, this is our definition in this slide. So next is dependent on the definition. A differential equation is said to be linear independent variable. Linear independent variable. So I am going to classify which given differential equation is linear or non-linear. Okay. So first of all, we have to explain something. Let us put that we have seen that y equal to fx. This is any function fx. Okay. So here x is an independent variable. Okay, independent variable, and y is dependent variable because y is dependent on the x. If we will give x, then we will get the y. So y is a dependent variable. Okay, so we will write y is a function of x, then we will do the derivative of this function dy dx equal to fx. Okay, so here x is a independent variable and y is a dependent variable. Okay, so now I want to classify the given differential equation is linear or not linear. So first point is that dependent variable is y. Okay, dependent variable was that y, and all its derivatives present are in first degree. Okay, means dependent variable y and all are its derivative in the degree of first. Okay, degree should be 1, means we will do derivative second order, third order, no problem, but the power of the derivative is only 1, linear. Okay, second point was that dependent variable and its derivative are not multiplied together. Dependent variable y, okay, dependent variable y and its derivative are not multiple together. If in any differential equation these type of the terms contains, so that differential equation is not linear. Okay, it may be like this. Okay, so third number point is that dependent variable and its derivative are not multiplied with itself. Okay, this is same as in a second point. Okay, so now I want to more classify the differential equation is ordinary differential equation or partial differential equation. So an ordinary differential equation is a differential equation which contains only ordinary derivatives like classical derivative is like this, d by dx. If any differential equation is contains this type of the derivative, so we can say ordinary differential equation. And if any equation OD, we can say in the short form ordinary differential equation. Okay, if it contains any classical order derivative or ordinary derivative, this type of the derivative. Okay, if a differential equation contains partially ordered derivative, this type of the derivative, del by del x, d square, del square upon del y square, then that equation is said to be partial differential equation. Okay, so we have to classify two types of the differential equation, ordinary differential equation and partial differential equation. Okay, so in this lecture series I am going to discuss only ordinary differential equation. Okay, so now I am going to discuss the order and degree of a differential equation. So the order of the highest derivatives involved in the differential equation, like we have an equation. Okay, y double dash plus pxy equal to qx, this is a differential equation. So in this equation we have an highest order derivative. Highest derivative is second order, so here order of this differential equation is second order. Highest ordered highest derivative exists, that is called the order of the differential equation. And what is the degree? Degree is the power of the highest order derivative. Means this is in this equation we have a highest order derivative is second, the power of is 1, so degree of this differential equation is 1. Okay, now I will take another example, y plus y double dash plus y dash equal to 2. So in this differential equation highest order is 3, so means order is 3 and the power of the highest order derivative is 2, so degree is 2. If let I will do the power here is 4, so then we can't say that the degree of this differential equation is 4. No, because the highest order derivative is 3, so the power of the highest order derivative is 2, so then we can say degree is 2, sorry 2. Okay, not 4. So this is a classification of degree and order of the differential equation. Next slide is related to the solution of a differential equation. So basically solution is a differential equation. A solution of a differential equation is a relation between the variables which does not involve any derivative and also satisfy the given differential equation. Okay, so we will see the help of the example. What is the solution? Let us suppose that we have in a differential equation y dash equal to y. Okay, now we will take a function y equal to fx type which have not contain any type of the derivative terms, and if we will put this function in given differential equation, that should be the satisfy. Okay, so let if I will take y dash equal to minus e to the power x. Okay, so if I will do the derivative, means we can also write y dash minus y equal to 0. First order derivative is minus e to the power minus x. Okay, so I will put here this is the differential equation. Okay, if I will put here minus e to the power x plus e to the power minus x equal to 0, so means this is the function which satisfy our given differential equation, so we can say that this is the solution of a differential equation. Okay, so in your mind is coming that ki how can we find this solution, how can you find this solution ki this will be the solution of a differential equation. So in the next lectures we will find how we will find the solution of that differential equation. Okay, ki how I find this solution. So I will explain more about the solution of a differential equation in the next lecture. Okay, so I think we should stop here. In the next video I will discuss the how can we find the solution of a differential equation. Okay, thanks.